what I attempted to describe very quickly. Let's go ahead and now graph these things, right? So the Euler's number and as you do this, it'll start approaching that number. Okay, because you're cutting up the interval into smaller and smaller units, and at all points in time means that goes to infinity, and when that happens, you get Euler's number. Okay, so let's see how the graph these. Well, we already looked at the graphs earlier. So if you have a growth factor or a base greater than 1, then the graph is going to look like this. And this would have been the A value. And so it's growing as it goes to the right, and as it goes to the left, it gets smaller. And notice they got a horizontal asymptote right here at y equals 0. Well, if your growth factor or your base is less than 1, between 1 and 0, that would be a decrease. And so notice as it decreases, it's gradually dropping down to 0. And so notice again the same horizontal asymptote. Okay, so this function would be like a 2 to the x or e to the t. And this function would be like a 1/2 to the x or e to the negative t, which is another way of saying 1 over e to the t. But people will use this instead. All right, well, let's now go ahead and do some transformations. Let's say we had -3 to the x. Now keep in mind, that negative is not part of the 3. You're going to change the sign after you raise 3 to some exponent. All right, so this would be a reflection across the x. So instead of looking like that, it's going to flip over and look like this. And so now, normally, the a would have been 1. Now, right here, this is -1. And you can see that's true. If you replace x with 0, 3 to the 0 power is 1, and then we change the sign. All right, now what if you had this? Okay, well, that changes the sign of the x, so that's going to flip it across the y-axis. So normally it would have looked like that, or now it's going to flip across the y-axis, it's going to look like that. Okay, and then here that would be 1, because if x is 0, and 3 to the 0 is 1. And notice that the horizontal asymptote isn't changing. That's only going to change if you go up and down. Okay, so we had a reflection across the x, a reflection across the y. All right. Okay, now let's look when we have multiple transformations. Okay, so let's see, throw an e in here. So let's say we had -2 minus e to the -t. Okay, well, the parent is e to the t. That's the parent. So this would have been the original graph. Okay, and it looks like we're dropping down 2, so that's a vertical transformation. I'm going to save that for last, and it looks like we got a reflection across the y and a reflection across the x. So I'm just going to do that at once, right here, and write that. And then we got a vertical translation -2, which would be the end resulting function. Okay, so flip it across the x, flip it across the y. Okay, so originally it looked like that. We flip it across the x, and then we flip it across the y. So right now, this is where we're at. Okay, and that's -1. Okay, so again, this is where we're at. That's the red graph. All right, and notice the horizontal asymptote hasn't changed because we're just flipping across the x and flipping across the y. Originally, this was 1. Once you flip it across the y, it stays there. Once you flip it across the x, it's over here at -1. Okay, and then the last step, this is dropping down 2. So this is dropping down 2. So the y equals 0 is going down, and the point on the y-axis is going down. So that means right here, -2, and right here at -3, that's the graph. All right, so two things to focus on with this one. The y-intercept, which is when x is 0, or t, depending on your variable, and where's the horizontal asymptote going. So if you don't have any translations, if you're not going up and down, if there's no vertical translation, the horizontal asymptote's not changing. Okay, let me make sure I got time correct. All right, good. Okay, I was worried we weren't going to be able to do a few things. That's cool. So let me now look at if we have something where we have a horizontal translation. Okay, so let's say we had 3 minus 10, and we'll just put x plus 1 there. Or rather, let me use one with a base that is less than 1. All right, so let's say this is 1/3. Okay, well, our parent function, so originally this would have been the graph, and when x is 0, that's 1. Okay, and it looks like next thing would be the fact that that's minus, so that means we're going to change the sign of the output. So then we're going to have reflection across the x. And then we got a horizontal translation. This is going to be to the left, -1. And then we got a vertical translation up 3. Okay, so horizontal translation -1, vertical translation +3. And I'm just combining those into one step. All right, so our original function, the parent, and then the transformations. So here's our parent. It's that graph. Okay, and then that's 1. Horizontal asymptote is still y equals 0. Y-intercept is 1. Okay, now we reflect that across the x, so that's going to go here. And now the y-intercept is -1. Horizontal asymptote hasn't changed. Okay? Now, if we move that to the left, that's not changing the horizontal asymptote. So if we do the horizontal translation to the left, that means this is going to go right here when x is -1. And so the y-intercept is going to go up a little bit. All right? And you could find out what that is by just replacing x with 0 if you wanted to find out what that is. But we don't need to know that. Now we're going to go up 3. So if we go up 3, that means the y equals 0 is going to go up 3. And if we go up 3, that means this point right here is going to go up 3. It's going to go up to y equals 2, x equals -1. And now we have that graph. Okay?